And today we're going to see some kind of dedicated Databricks features for SDP. Let me first start by deploying the bundle with all the demo parts inside. So typically we are going to see the continuous trigger with some per table configuration, a custom ForeachBatch sync that you can use on Databricks. We are going also to check how to pass parameters and how to leverage private tables, so there's kind of intermediary storage inside your pipeline, which is not exposed to the users via Unity catalog. And yeah, that's all for that. And let's get started. I will deploy the bundle. And at the same time, I will create a structure for the first demo, which is the private table demo. So let me go to the SQL editor. And yeah, I will start by creating a simple numbers table. Because in this demo, what is most important is not necessarily the data, even though in real life it's not the case, right? Because you worry about the data a lot. But here we want just to check the logic, all the runtime mechanism behind Databricks and Lakeflow Spark Declarative pipelines. Okay, so the query is running. Let me check if I have all the pipelines already. And yeah, we have the pipelines for the demo. And as I said, we are going to start with this private table, sorry. And when I check the source code, it's very simple currently, because we decorate the table. We use generally the same decorator as previously, like table for streaming table, but we are declaring it as private, meaning that these numbers with processing time table will not be exposed via Unity catalog for querying. It will be available only within the pipeline for the purpose of this execution. So typically I'm expecting here to have this current timestamp value be the same for both tables, meaning that it was some kind of materialized in the pipeline, right? Because otherwise it would be a different streaming query, and very possibly there will be a significant difference in the current timestamp value. Okay, so let's run the pipeline. And as you can see, our tables are now streaming the data that is present in the input. And the first thing I can show you now is it's somewhere a kind of open table button. View table performance. Oh yeah, this is the button I was looking for. Is the view in the catalog, where you can directly go to your Unity catalog and verify the table which is managed by the SDP pipeline. But when you click on the button for the private table, you will see that yeah, there is some kind of hidden table, but there are a lot of limitations, in fact, right? And as you can see, our pipeline already executed the first iteration. And let's maybe check the data in the catalog for the processing time. It's 02:39:672, and it's exactly the same here. And by the way, this was something that's changed now, because when I did this demo for the first time, when I clicked on this view in the catalog button, the table was not here, but now you can visualize the schema and some kind of other details for this private table alongside, for example, the size or any other storage statistics. And we can also have this sample data, yes. But as you can see, this table is not visible in the public list. You can only access it through this view in the catalog button. So that was the first demo. The second one is about input parameters. And the input parameters, and I check the code. We are going to take the input parameter called expected modulo, and we are going to filter out all records that don't match this expected modulo parameter. Okay, the pipeline has completed. Let's now check the content of the table. Logically, we should find two numbers, which are 2 and 4. Okay. Maybe now I will change the modulo in the input parameters. Put it, sorry, it was 0. I will put it to 1 and try to redeploy the pipeline. And I will refresh the table. So I will run the, oh sorry, I just should have stopped it. And I will run the table with a full refresh. And when I check the sample data yet again, on this number module, I should see, yeah, I should see different numbers. So as you saw, there's a pretty easy way to configure your Spark declarative pipelines just with the help of, it's here, Spark config, like Spark config getter. Let's see now the ForeachBatch. The ForeachBatch is like the ForeachBatch thing in Apache Spark structured streaming, meaning that you can use kind of many writing operations or even kind of internal transformations inside this ForeachBatch function. And how to use it? You need to declare the append flow and later configure the target which calls the name of your ForeachBatch sync, which it's decorated on its own, by the way, so that's the name. And in the demo we are going to show the content of the numbers table, create the table if it's the first run, and later also count the number of rows. So let me run the pipeline now. Okay, the pipeline is up and running. And if we check now the logs, we should see our operations executed as part of the ForeachBatch sync. So the count, the print, and also I should have a table created just here, which is this table, numbers for each sync. Okay, so yeah, it gives you some flexibility, of course, but it also, with this power comes responsibility, because you need to deal with the table creation logic, of course, like here, when you override with the first execution, but you do the append for the next executions, and so forth and so on. Now it's time to move on and see the final demo, which is about continuous trigger. So the continuous trigger, I already blocked it, I think. Let me check if I have this block published. Yes, we have the continuous trigger for Lakeflow jobs, and this is the same principle for Spark declarative pipelines, because your job is continuously running, right? If there is a failure, it will automatically retry based on some kind of backup policy, and for the Lakeflow jobs, it will use new clusters. What about the Spark declarative pipelines demo? We have this one. Where the job simply streams the numbers table and writes the data to the numbers for continuous trigger streaming table. But you will be a little bit puzzled, right? I will show you why. If you take a look at the configuration we have deployed a few minutes ago, you will see that we clearly specified all the continuous configurations, like the triggering mechanism, like the trigger interval for the pipeline itself. But when you check the deployment result, you will see that the pipeline is not running. By default, when you deploy a continuous job on Databricks, it will be up and running from the first seconds, right? And here, a few minutes passed and the continuous trigger job is still not running. And the reason for that is the declarative automation bundles development mode that not only adds some user prefix to the jobs, but it also kind of disables the continuous character of the jobs, right? And it makes sense, because if you have many users who want to test their pipelines, you maybe don't want them to run all this in parallel, possibly consuming the same input data and writing to the same output tables. That would be very difficult later to analyze and to validate their work. So because of this development mode, the continuous trigger is disabled by default. Okay, so let me now comment this development mode, and I also renamed the previous continuous pipeline just to not confuse yourself, and I will deploy it with all the changes. And after deployment, my continuous pipeline, yes, you can see that it's running, it's waiting for resources. And since the trigger for this pipeline is set to 2 minutes, it will refresh the data every 2 minutes globally. So it's setting up the tables. And as you can see, it generates 5 output rows to the table. Okay, the table is there. I have the data probably. Or not yet. No, it's not yet ready. Okay, I have my first 5 records. So remember the refresh time. I will now add 3 new rows. And we will have to wait 2 other minutes to see this continuous trigger interacting with the input table, taking the data and writing it to the output streaming table. Okay, and if I add another record, because the previous one was not really true. Okay, I added one record. Let's see the sample. So after 2 minutes, the pipeline added the 3 additional records, and now typically somewhere near to 4 minutes probably of the runtime, the pipeline should take yet another record. So my record number 12. Okay, yes, you can see that after 4 minutes, so globally the third iteration, we just ingested the record number 9, which corresponds to the value number 12. Okay, so that was for a single schedule. But what's different is that you can have different intervals per job. So it's the case of this continuous trigger per table pipeline, where we have one table refreshed every 2 minutes and another table refreshed maybe every, like let's keep it every 5 minutes. Okay, so I will deploy now the bundle that will of course remove the previous continuous demo, because I just kind of undeclared it in the resources by renaming the YAML file to text file, so that it's not visible to this include prefix. And logically, the second continuous pipeline should start. So waiting for resources again, initializing, setting up the tables. So this table doesn't exist anymore. Okay. Do we have our tables? Not yet. Okay, you can see that we have started two tasks, 2 jobs in this in this pipeline. One which is the full recompute for the materialized view, and another one which is the streaming table here. Okay, so we have this output records 9, and now I will add a new record, maybe 20. And this new record should be, according to these triggers, integrated in 2 minutes for the streaming table and in 5 minutes for the materialized view. Okay, so just let me check the tables. We have our 9 rows generated so far in our demo, and now we just have to wait a few more minutes to see the additional record, the record number 20, integrated to those tables. Okay, are we close to refresh? Yes, we are. We have just refreshed the streaming table with the new record. And the materialized view will probably need to wait like maybe roughly 3 more minutes to be refreshed. So here we have our record logically, yes. And now we will need to wait a few more minutes for the materialized view to be refreshed. And the streaming job, sorry, just stopped, but the pipeline is still running, right? Because it's a continuous trigger. And like probably in a few seconds, the materialized view should ingest the new record to its table. Okay, will it be the case or not? Okay, yes. The job for the materialize view just detected some change in the input table and started the executing the logic, and as you can see we have now 10 output records in this part. And if I refresh my sample table, I should see it in this sample. Yeah, we have now the same data, but as you saw here, with two different refresh mechanism. So, okay, and that's all for today, for today's demo. You saw a few different things that extend a little bit the Lakeflow Spark Declarative Pipelines concepts you learned 1 week ago. So just to highlight them, in the first part you discovered the private table as a kind of internal buffer that is not exposed publicly in Unity Catalog, which is available to your pipeline as a kind of intermediary storage if you want to apply and write some kind of fan-out pattern when you process the data in one place and later you write it maybe with slightly different transformations to other tables. That was the first part. The second demo was about the input parameters, so something that can help you make the pipelines more dynamic. We saw it with these modulo examples when we changed the modulo and automatically with the full refresh involved a different output. Third, you discovered the ForeachBatch sync, which is the Swiss knife in Spark structure streaming, and now you see that it's also available on Databricks for Spark declarative pipelines. And finally, and in the end, we saw two phases of the continuous trigger. Well, technically three, because we started with this bundle with the development mode activated, which by default disables the continuous trigger. Later we deployed a continuous trigger pipeline without this development mode, and you saw that it started immediately after the deployment. We also discovered the triggers part, so that the proof that the refresh is not instantaneous, so that like it behaves a little bit like the triggers instructor streaming, when the processing time trigger, instructor streaming, when you define how often your micro batch query should be executed. And now, in just few minutes ago, we saw how to configure different triggers per job being part of the same pipeline. So thank you for watching, and see you in the next demo or in the next blog post. Of course, all additional details and code you will find in the blog post, which is linked just in the description of this video. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.